In this video, we will practice evaluating expressions involving inverse trig functions. As we do this, we have to keep in mind that there are restrictions placed on inverse trig functions. For inverse sine or arc sine, the answers can only be between negative pi over 2 and positive pi over 2, so the right side of the unit circle. For inverse cosine, also known as arc cosine, the answers can only be between 0 and pi, so the top part of the circle. And for inverse tangent, also known as arctangent, the answers can only be between negative pi over 2 and positive pi over 2, not including negative pi over 2 itself or positive pi over 2 itself, where tangent would be undefined. So the right side of the unit circle. So an inverse trig function is just an angle. It's the angle, in this case, whose tangent is equal to negative 1. So we're asking what angle has a tangent of negative 1. A long time ago, you should have memorized the information that is on this chart. So I am going to assume that these facts are in your brain. If they are not in your brain, then you need to just pause this video and take this time to memorize the facts that are on the screen. But for now, if I want to know what angle has a tangent of negative 1, first I ignore the negative 1 for just a minute. What angle has a tangent of 1? So that's one of those things on the chart. Tangent of pi over 4 is equal to 1. So that tells me the reference angle is going to be pi over 4. Alright, the answer can't be pi over 4 because that would give us positive 1, not negative 1. So the reference angle is pi over 4. So here is a picture of a bunch of pi over 4 angles. Now these 4 angles, all 4 of them have a reference angle of pi over 4. It's just that 2 of them are positive and 2 of them are negative. Tangent is positive here and here. Tangent is negative here and here. Because we want a positive angle, we want a negative 1, then we can forget about this and this. So it's got to be one of these 2 angles will be the answer. And then we consider the restrictions. Inverse tangent can only be on the right side of the circle, so that takes out this option. So that means this is the answer. And then the only thing left is to be careful about what we call it. In the past, we might have called this angle, the angle that has this terminal side, we might have called it 7 pi over 4, something like that. But we can't call it 7 pi over 4 this time because of the restrictions. Inverse tangent can only be between negative pi over 2 and positive pi over 2. We can't wrap around the long way and go past pi over 2, even if the terminal side winds up back in the restricted range. It went outside of it as we rotated it around to get there, so that would be illegal. So instead, all we can do is go the short way, which would be negative pi over 4. That keeps us within the restricted range, the right hand side of the circle, so that's okay. So that's the answer. So the answer is going to be negative pi over 4. Alright, moving on to problem number 2. I'm going to work this problem from the inside out. First, let's find the inverse cosine of negative radical 2 over 2. Again, let's ignore the negative sign for a moment and ask ourselves, what angle has a cosine of radical 2 over 2? By the way, radical 2 over 2 is the same thing as 1 over radical 2. So, inverse cosine is just an angle. It's the angle whose cosine is radical 2 over 2, or 1 over radical 2. That's one of those facts that, again, we have memorized. The cosine of pi over 4 is radical 2 over 2. So, the answer would be pi over 4 if it weren't for this pesky negative sign. But again, that pi over 4 means that the reference angle is pi over 4. So let's look back at our pi over 4 picture again. Okay, so again, here's our pi over 4 picture. Again, there are 4 angles that have a reference angle of pi over 4. This time we're talking about cosine. Cosine is positive on the right side because cosine is the x value on the unit circle, and cosine is negative on the left side. So we are looking for a negative result. So for that reason, we can forget about these two possibilities. So it's going to be one of these two for the answer. But then the restrictions. Cosine can only be between 0 and pi. So that is going to eliminate this choice down here. So this is the answer, and this is 3 pi over 4. So that's the answer. Well, that's not the final answer. We were just doing the inner part of the problem. So that was 3 pi over 4. Now we have to do the outer part. We have to go ahead and find the cotangent of this. Well, when I do the cotangent, the first thing I ask myself is, what is the tangent of 3 pi over 4? Okay, because I know these are just reciprocals of each other. So what's the tangent of 3 pi over 4? Well, the reference angle obviously is pi over 4. So if I consider my chart, I know that the tangent of pi over 4 is 1. So then I know the answer is going to be some type of a 1. So let's see, where's my circle? So at 3 pi over 4, the question is tangent positive or negative right here? Well, tangent is positive, remember, here and here. Tangent is negative here and here. So here at 3 pi over 4, tangent is negative. So that tells me that the tangent of 3 pi over 4 is negative 1. And then the cotangent is going to be the reciprocal of this. The reciprocal of negative 1 is still negative 1. So that's going to be the answer. Okay, let's keep going and look at the inverse sine of negative radical 3 over 2. Well, let's find the reference angle by ignoring the negative sign. Inverse sine is just an angle. It's the angle whose sine is radical 3 over 2. So if there were no negative sign, I would just be thinking about my chart. Okay, the sine of pi over 3 is radical 3 over 2. So that tells me that the reference angle is pi over 3. Okay, that's the reference angle. Now, pi over 3 is not the answer because there is a negative here, and the sine of pi over 3 is positive radical 3 over 2. So that is not the answer. But it tells me what image I should be picturing in my mind. So, these are the 4 angles that have a reference angle of pi over 3. Now, all of these will give me a sine of some kind of radical 3 over 2. But 2 of them will be positive, all right, because sine is positive above the x-axis because it is a y value. And 2 of them will be negative. Now, in this case, we want a negative answer, so that means we can forget about these 2 up here at the top. Also, we consider the restrictions. Inverse sine is restricted to the right side of the unit circle, between negative pi over 2 and positive pi over 2. So keeping that in mind, that eliminates this option over here. So this is the only option, and we have to be careful to call it negative pi over 3. All right, that keeps it within the right-hand side of the unit circle. We cannot call it 5 pi over 3 going around the long way, because that takes us outside of the restricted range. So we'll call it negative pi over 3, and that's the answer. Okay, let's keep going. Let's look at problem number 4. Inverse cosine of 0. This is an angle. It is the angle whose cosine is 0. So what angle has a cosine of 0? Now that's not one of the things on my chart, but it is a quadrantal angle. So let's think about the coordinates of these positions. This is 1, 0. This is 0, 1, negative 1, 0, and 0, negative 1. Now, cosine is the x value on the unit circle. So we are looking at just the x values. Now again, this is the angle whose cosine is 0. So what angle has a cosine of 0? Okay, so these two angles have a cosine of 0, all right, up high and up low. So we can forget about these, so one of these two angles will be the answer. However, cosine has to be between 0 and pi. So that means we can forget about this one down here. This one must be the answer. This is pi over 2. So that's the answer. For number 5, the inverse cosine is the angle whose cosine is this number, negative radical 2 over 2, also known as 1 over radical 2. To see what the reference angle is, ignore the negative sign for a moment. So what angle has a cosine of radical 2 over 2? Hopefully you have memorized that that is pi over 4. Alright, cosine of pi over 4 is radical 2 over 2. So that's the reference angle. So I can come back to my picture of pi over 4s. So these are the 4 angles that have a reference angle of pi over 4. Now, all of these will have a cosine of radical 2 over 2, except these two will be positive, alright, because cosine is positive on the right-hand side because it's an x value, and these two will be negative. So, for this particular problem, we want negative radical 2 over 2. So that means we can forget about these two answers right here. So it's going to be one of these. And then we remember that inverse cosine can only be between 0 and pi. So that tells us that this lower one cannot be the answer. So that means this is the answer right here, and this is 3 pi over 4. So that's it. That's the answer. It's 3 pi over 4. Okay, let's look at number 6. I'm going to work from the inside out. So first I'm going to figure out what is the sine of 5 pi over 6. Obviously the reference angle is pi over 6. Here are a bunch of pi over 6's. Alright, this is 6 pi over 6 would be right here. 5 pi over 6 is right here. So we know that the sine of pi over 6 is 1/2, something we should have memorized. So it's just a matter of whether this is negative 1/2 or positive 1/2. It's going to be positive because sine is a y value, and this is above the x-axis, so that's going to be positive 1/2. So I have just discovered that the inner part here is positive 1/2. So now I have the inverse sine of 1/2. Well, this is the angle whose sine is 1/2. And that's just going to be the reference angle, which is pi over 6. So that's it for number 6. Number 7. Arc cosine is the same thing as inverse cosine. Alright, these two things mean the same thing. In both cases, it's the angle whose cosine is 1/2. That should be one of those things that we have memorized. This is going to be simply pi over 3. Okay, the cosine of pi over 3 is 1/2, so pi over 3. Okay, that was easy. So, number 8. Arctangent of this is the angle whose tangent is this right here. Now, this is not one of the special values, all right? We are not going to find 12 over 5 as none of these answers are 12 over 5. So this is not a special angle, so we're going to have to use a different strategy for this. So what are we going to do? Well, tangent is opposite over adjacent. Okay, so tangent is sort of the y value over the x value. So I'm going to go ahead and think about the two quadrants where inverse tangent is defined. Inverse tangent can only be in the first and fourth quadrant. So let's see. So could that be a negative x value? No. That would put me over here. So this negative 12 must be a negative y value. So I'm going to think of this negative sign as being up here on the y value. So I've got a negative 12 and a positive 5. I'm going to look at it that way. So here I go. If I have a positive 5 and a negative 12. In fact, let me redraw this so I'll have a little extra space. Okay. So I have a positive 5 x value and I have a negative 12 y value. So that would be something sort of like this. Okay, imagine that I had this point. Okay, and I'm forming a right triangle out of it. This would be a positive 5 x value for this point, and this would be a negative 12 y value because it's down 12. So, to do other trig functions, then I need the hypotenuse. Like the sine function, for example, involves the hypotenuse. So now this is one of my Pythagorean triples that I've memorized. This is going to be a 5, 12, 13 triangle. Alright, I've memorized that if I have legs of 5 and 12, the hypotenuse will be 13. But if you did not know that, then you would have done the Pythagorean theorem. You would have said a squared plus b squared is equal to c squared. And then that would have been 25 plus 144 is equal to c squared. That's 169. Take the square root. C is equal to 13. That's how you would have gotten it if you haven't memorized your 5, 12, 13. If you're interested, here is a brief list of the most common Pythagorean triples. If I see a 3 and a 4 for the legs, I know the hypotenuse will be a 5. If I see a 5 and a 12, the hypotenuse will be a 13. If I see an 8 and a 15, the hypotenuse will be 17. And it works the other way. If I see a hypotenuse of 25 and one of the legs is 24, I know that the other leg will be 7. These are the four most common Pythagorean triples. They are worth memorizing. Anyway, arctangent is an angle. It's the angle whose tangent is negative 12 over 5. Now, I don't know exactly what that angle is, but I have drawn it. So this right here is a picture of the angle whose tangent is negative 12 over 5. Now, the good news is I don't need to know exactly what that angle is to answer the question, because I just need to know what is the sine of that angle. what is the sine of the angle that I have drawn? Well, the sine of this angle that I have drawn is going to be opposite over hypotenuse. So that's going to be negative 12 over 13. So I can find the sine of the angle without actually knowing what the angle is, and that's going to be the answer. Okay. You know what, I guess I'm going to power through. Normally I try to stop a video when it's about 20 minutes, and we're hitting that 20-minute mark now, but I just have these 4 problems left, and we've gone so far. I think I'm just going to power through, and this is just going to have to be somewhat of a long video. So here we go. The inverse sine of 1/2. This is the angle whose sine is 1/2. We have memorized that that is pi over 6. All right, that's just right off the chart. So now I want the cosine of that angle. But the cosine of pi over 6 is radical 3 over 2. Again, that's just a value that we memorized off of the chart. Yeah, there it is. All right, both of those values were just right off the chart right here. So that's number 9. Number 10. The inverse tangent is the angle whose tangent is negative radical 3. So ignore the negative sign for a minute. So what angle has a tangent of positive radical 3? So that's going to be right off the chart. Okay, there's my positive radical 3. The tangent of pi over 3 is radical 3. So if it had been a positive radical 3, then the answer would have been pi over 3. But as it stands, pi over 3 is not the answer, but it is the reference angle. So I'm going to go to my picture of pi over 3's and think about how this works. These are the 4 angles that have a reference angle of pi over 3. Now tangent is positive in these quadrants, and it is negative in these quadrants. So for this particular problem, I want negative radical 3 for the answer. So I can forget about these 2 angles. Now, because of the restricted range for inverse tangent, I know I can only be in the right side of the circle. Alright, I can only be over here. So that's going to mean that this is no good. So this is the only remaining angle. So the answer must be negative pi over 3. I cannot call it 5 pi over 3. I have to call it negative pi over 3. So that's the answer. Okay, number 11. Secant. Well, this is a reciprocal trig function. This is the reciprocal of the cosine. Alright, so first let's ask ourselves, what is the cosine of negative 11 pi over 3? And then the secant will just be the reciprocal of that. Okay, so what is the cosine of this? Well, let's start with the reference angle. The reference angle, of course, is pi over 3. I can see it right there. And I've memorized that. The cosine of pi over 3 is 1/2. So this is going to be some version of 1/2. It's just a matter of, will it be positive 1/2 or will it be negative 1/2? And that just depends on the quadrant. Where is negative 11 pi over 3? Well, let's look at the picture. Alright, here are a bunch of pi over 3's. Starting from here. If I go negative, that means I'm going clockwise. See how there's 6 of these? So if I go around once, that's negative 6. Okay, if I went around again, that would be negative 12. But I wanted negative 11, so I'm going to stop one short of that. Okay, I'm going to stop here. So this would be negative 11 pi over 3. So based on the fact that it is in the first quadrant, everything is positive in the first quadrant. So I know I am looking at a positive 1/2. But then, of course, the secant is the reciprocal of cosine. So the reciprocal of this will be 2. So that's going to be the answer. Okay, and then finally, number 12. I'm just going to work this from the inside out. Remember that radical 3 over 3 is the same thing as 1 over radical 3 if you memorized it that way. But this is one of the values off our chart. So the inverse tangent is the angle whose tangent is 1 over radical 3. And we've memorized that that is pi over 6. Okay, the tangent of pi over 6 is 1 over radical 3. So far I know that the inner part is pi over 6. That's the angle. Fine, so now I must evaluate the cosecant of pi over 6. Well, cosecant is the reciprocal of the sine function. So what is the sine of pi over 6? What I'm going to ask myself next. We've memorized that that is 1/2. So the cosecant is going to be the reciprocal of that, which is 2. So that's why the final answer is going to be simply 2. And that's going to do it for this video. I will see you on the next video.